என்ன பண்ணிட்டு இருக்கீங்க நீங்க next one half wave rectifier full wave rectifier. So what do you mean by rectifier?
It's an electronic device. It's rectifies AC supply to DC supply.
Okay, AC supply to DC supply. இப்போ என்னென்ன components யூஸ் பண்ணி என்ன பண்ணிட்டு இருக்கீங்க இத?
இங்க வந்து ஒரு சென்ட்ரல் டேப் ட்ரான்ஸ்ஃபார்மர் யூஸ் பண்றாங்க.
ஓகே.
இது ஒரு டயோட் PNC டயோட் யூஸ் பண்றாங்க. ஸோ இது ஒரு ரெசிஸ்டர். அப்புறம் கெபாசிட்டர் யூஸ் பண்றாங்க.
Capacitor, okay.
CRO.
Cathode oscilloscope. So in the oscilloscope, what you are going to see in this oscilloscope? Waveform. We can see the sine waveform. Okay. Now we are doing half wave rectifier, right? So you can see the half wave sine. Okay. Now, how many diodes are using in the half wave rectifiers? One diode. Okay. What is the connecting terminal of the diode? Connecting terminal. Positive, negative, and it's also known as anode, cathode. So when it is known as forward bias,
when positive is connected to the cathode, it is known as.
When positive terminal of the battery is connected with the positive terminal of the diode.
Okay, positive terminal of the battery is connected with the positive terminal of the diode. That is connected with the anode. So it is known as forward bias. When it is known as reverse bias,
when the positive terminal of the battery is connected with negative terminal of the diode.
Negative terminal of the diode. Okay. So first of all, how you connected this experiment? So now here we have what type of transformer we used? Center tap transformer. So what is the difference between center tap and normal transformer? So we are splitting the supply. So in center tap transformer, we are splitting the supply. You can see here it is. So we are splitting the total 12. We are receiving 12 volt supply. We are splitting that 12 volt supply into two 12 volt supply. So 12 volt and 12 volt supply. So in this, in the half wave rectifier, we are going to use only this 12 volt supply. So this transformer is connected with anode of a PN junction diode. This half wave rectifier is connected with the anode of a PN junction diode, and the PN junction diode is connected with the, what is this? Load resistor. So it is connected seriously or parallelly? Seriously. Okay. So the diode is connected seriously with the load, and we are checking the load resistance. We are checking the load resistance with the help of CR. Okay. Here we can see. So we can see the half wave rectifier, half waveform. So here the one box represents how many points? How many points? So one box represents how many points? 5 points. So each line represents 0.2. Then one box represents 1 1. So this represents how you gave connection in this breadboard now? Can anyone explain the connection?
PN junction diode is connected with the series to the load resistance.
Okay.
The load is connected
the
to
output from the center tap transformer at 1 volt is connected to the PN junction positive terminal, so forward bias okay. So the load resistor is connected with series.
Okay. So why this diode is not working in reverse bias?
If the diode is connected in reverse bias, the depletion layer will increase. The depletion layer will increase, so the connectivity won't be there.
Connectivity won't be there. Okay, good. Correct. So we are not getting the negative half cycle, right? We are getting only the positive half cycle. So because of this depletion, increasing of the depletion layer, we won't get the reverse bias connection. So the supply is 0 here. Okay. So that's all about half wave rectifier. Okay, you can complete this. Okay, now you have seen a half wave rectifier. Now coming to full wave rectifier. So in full wave rectifier, how many types we have in full wave rectifier? 2 types. What are the 2 types? Center tap type and rigid type. So in center tap type, how many diodes we are using?
4.
In In center tap type, generally we are using 2 diodes. Good. 2 diodes. In bridge type, 4 diodes. So based on efficiency, half wave rectifier is good or full wave rectifier is good? Full wave rectifier. So how many percentage of efficiency we are getting? We are totally converting the AC supply to DC supply. 81.6%. Okay, good. So now coming to the bridge rectifier, we are using 4 diodes. In 1/2 seconds, how many diodes will turn on? 2 diodes will turn on at that time. Coming to center type transformer, how many diodes will turn on? One diode, because we are using two diodes. So in 1/2 second, 1 diode will turn on. Okay. Next, coming to application where particularly we are using this rectifier.
It is used in home appliances, like
Yes.
converting wherever the AC supply to DC supply is converted, we use a rectifier.
Wherever we need DC supply, there we are using the rectifiers. So we have so many applications. Examples: clippers, clampers. And we have so many applications. So what do you mean by clippers means? If you are seeing that this is a sine waveform. If you have here we have a disturbance, right? It is not pure sine waveform. Okay. So here we have disturbance. So now we have to remove the disturbance. Here we have the disturbance. We have to remove the disturbance. So what we are going to do? We have to clip. What do you mean by clipping? Just we cutting off. Clipping off. So what we are doing is we are cutting off this disturbance with the help of diode. With the help of diode, we are just cutting off this disturbance. So that is clippers. Clippers means we are cutting the disturbance in sine waveform. And clampers. So clampers means what? Clamping. What do you mean by clamping?
Getting hold of.
Getting hold of and lifting something. So what we are doing is clamping. We are totally shifting the sine wave from 0 level to upper level. Okay. So that is clamp. Okay. That's all about rectifiers.